Alright, let's do the math. Number 10. The scale of the universe. The observable universe contains 2 trillion galaxies. 2 trillion. The Milky Way alone holds between 200 and 400 billion stars. Roughly 20% of those stars are sun-like. Studies now confirm that nearly every star has planets, and approximately 22% of sun-like stars have an Earth-sized planet sitting in the habitable zone, the orbital band where liquid water can exist on a surface. Run those numbers. In our galaxy alone, that gives you a conservative estimate of 8.8 billion potentially habitable Earth-like planets. 8.8 billion. Now ask yourself a question. What is the probability that across 8.8 billion chances, across billions of years, across the most common chemistry in the universe, not a single one of those planets ever produced life? Mathematicians have a term for numbers this small. They call them negligible, indistinguishable from zero. The probability that Earth is the only inhabited planet in the Milky Way is not just unlikely. It is, in formal mathematical terms, essentially impossible. And we haven't even left our own galaxy yet. Number 9. The Miller-Urey experiment and the inevitability of life's chemistry. In 1952, a graduate student named Stanley Miller, working under Nobel laureate Harold Urey at the University of Chicago, built a glass apparatus the size of a kitchen cabinet. He filled it with methane, ammonia, hydrogen, and water vapor, his best reconstruction of early Earth's atmosphere. Then he ran an electrical spark through it, simulated lightning. He let it run for a week. When he analyzed the residue coating the inside of the glass, he found amino acids, the molecular building blocks of proteins, the scaffolding of life itself. Miller had not created life, but he had done something arguably more significant. He had demonstrated that the chemistry of life does not require a miracle. It does not require divine intervention or billion-year waiting periods or exotic alien conditions. It requires hydrogen, carbon, oxygen, and nitrogen, the 4 most abundant reactive elements in the universe, and an energy source. Any energy source. The experiment has since been replicated dozens of times, with different gas mixtures, different energy sources, different temperatures. Amino acids form, every time, spontaneously, inevitably. The origin of life's raw ingredients is not a mystery, it is chemistry, and chemistry, given the right elements and energy, does not have a choice. Number 8. Amino acids and meteorites. The universe is already coking. In 1969, a meteorite exploded over Murchison, Australia, scattering fragments across a wide area. Scientists collected the pieces. They began analyzing the interior, material locked inside solid rock since before the solar system formed, 4.5 billion years ago. They found amino acids. The scientific community resisted this immediately. Contamination, they said. Earthly organic matter had infiltrated the sample. But the amino acids inside the Murchison meteorite had a distinct molecular signature, a mix of left-handed and right-handed versions that does not occur in Earth biology, which uses only left-handed amino acids. This was not contamination. This was extraterrestrial chemistry. The Murchison meteorite contained over 90 different amino acids. Earth life uses 19. The universe apparently is not limited by our biology. Since then, amino acids have been found in meteorites collected from Antarctica, in interstellar dust clouds detected by radio telescopes, in comets visited by spacecraft. The universe is not waiting for planets to start producing the chemistry of life. It is producing that chemistry in open space, in molecular clouds, in the cold void between stars, without any planetary surface, without any liquid water, without any of the conditions we assumed were necessary. The ingredients of life are not rare. They are the default. Number 7. Extremophiles. Life does not respect our definitions. We used to have a clear picture of where life could exist. It needed moderate temperatures, liquid water, sunlight, reasonable pressure, a stable environment. Then we found hydrothermal vents at the bottom of the Pacific Ocean, complete darkness, crushing pressure, boiling water laced with toxic chemicals, crawling with life, tube worms, shrimp, microbial mats so dense they coat the rock like carpet. Then we found bacteria living in solid Antarctic ice, thriving in pools of concentrated sulfuric acid, colonizing the cooling rods of nuclear reactors, feasting on ionizing radiation that would kill a human in minutes. We found microbial life in the Atacama Desert, the driest place on Earth, inside translucent salt crystals, metabolizing light directly through the crystal walls. We found life kilometers underground, in solid rock, subsisting on chemical reactions between water and stone, with no sunlight, no organic input from the surface, completely isolated from the biosphere above. These organisms had been sealed in that rock for millions of years. They were alive. Every time we define the outer boundary of the habitable zone, the conditions beyond which life cannot exist, we found life there. Not struggling, not barely surviving, thriving, adapted, evolved specifically for conditions we declared lethal. The habitable zone is a human concept. Life did not get the memo. Number 6. Phosphine on Venus. Hell is not uninhabited. In September 2020, a team led by astronomer Jane Greaves published a paper in the journal Nature Astronomy. They had been using the James Clerk Maxwell Telescope in Hawaii and the Atacama Large Millimeter Array in Chile. They had aimed both instruments at Venus. They detected phosphine. Phosphine, pH 3, is a molecule with a very short list of natural production methods. On Earth, it is produced industrially, in certain anaerobic microbial environments, and through biological decay processes. That is it. No known geological process produces phosphine in significant quantities. No known photochemical process. No known volcanic reaction at concentrations anywhere near what was detected above Venus. The concentration in the Venusian cloud layer was 20 parts per billion. This is orders of magnitude higher than any non-biological source can account for. The paper caused immediate explosive controversy. Multiple teams attacked the methodology. The signal strength was later revised downward, not eliminated, revised. The debate over the precise quantity continues, but no team has produced a confirmed abiotic explanation for phosphine at those altitudes on Venus. Venus is the most hostile planet in the solar system. Surface temperatures of 465 degrees Celsius, crushing atmospheric pressure, sulfuric acid rain, but the cloud layer 50 kilometers up, with temperatures around 30 degrees Celsius and Earth-like pressures, is theoretically the most Earth-like environment in the solar system outside of Earth itself. The phosphine signal has not been fully explained. It has not been retracted. The controversy is ongoing, and no one has closed the door. Number 5. The habitable zone is everywhere. For decades, the search for life outside Earth focused on the Goldilocks zone, the narrow orbital band around a star where a planet's surface temperature allows liquid water. Too close, the water boils. Too far, it freezes. Only in that narrow ring could life possibly exist. Then the Voyager and Galileo spacecraft sent back images of Europa, a moon of Jupiter far outside any traditional habitable zone, perpetually frozen on its surface, with evidence of a liquid water ocean beneath the ice. A global ocean, larger than all of Earth's oceans combined, kept liquid by tidal forces from Jupiter's immense gravity. Then, Cassini discovered Enceladus, a moon of Saturn, venting plumes of water ice, organic molecules, and molecular hydrogen from beneath its icy surface into space. A confirmed subsurface ocean, active chemistry, energy from hydrothermal vents on the ocean floor. Then Ganymede. Then Titan, with its methane lakes and complex organic chemistry. Then Pluto, with possible internal ocean evidence. The outer solar system, the dead zone, the frozen wasteland, the region no one considered, is full of liquid water oceans. None of them receive meaningful sunlight. All of them have chemistry. Some have energy sources. The habitable zone is not a band around a star. It is any location in the universe where liquid water, chemistry, and energy coexist. When you redefine the habitable zone this way, the number of potentially inhabited locations in the Milky Way does not increase modestly. It increases by several orders of magnitude. We were looking in the wrong places. Number 4. The WOW. Signal, 72 secons that changed everything. August 15th, 1977. The Big Ear Radio Telescope at Ohio State University is conducting a survey of the sky. Astronomer Jerry Amon is reviewing the computer printout of the telescope's data, columns of alphanumeric characters representing signal intensity. At 11:16 p.m., the telescope sweeps across a region of sky in the constellation Sagittarius. The printout shows 6EQ-UJ5. In Big Ear's notation, this represents a signal that rose rapidly in intensity, peaked at a strength 30 times louder than the background noise of deep space, then faded, perfectly consistent with a point source of radio emissions sweeping across the telescope's field of view as the Earth rotated. Exactly what a signal from a distant transmitter in space would look like. The signal was at 1420 MHz, the hydrogen line, the frequency of the electromagnetic emission of hydrogen atoms, the frequency that physicists and astronomers universally agreed for decades would be chosen by any advanced civilization attempting interstellar communication, because hydrogen is the most common element in the universe, and any spacefaring civilization would know that frequency. Eamon circled the sequence in red ink and wrote one word in the margin: wow. Dozens of follow-up observations have scanned that region of sky with increasingly sensitive equipment for 47 years. Nothing. The signal has never been explained. No natural astrophysical phenomenon produces a narrowband signal at 1420 MHz with that profile. No satellite, no Earth-based source, no known natural emitter accounts for it. After nearly 5 decades, the WOW signal remains the single most compelling candidate for an extraterrestrial transmission in the history of radio astronomy, and it lasted 72 seconds. Then it was gone. We have never heard it again. Number 3. The TRAPPIST-1 System, the template for a universe full of life. In February 2017, a team using the TRAPPIST telescope in Chile and follow-up observations from Hubble and Spitzer announced something that restructured the search for extraterrestrial life overnight. A small, dim red dwarf star 39 light-years from Earth, designated TRAPPIST-1, has 7 rocky, Earth-sized planets. All 7 orbit closer to their star than Mercury orbits our Sun, yet 3 of them sit squarely in the habitable zone, because TRAPPIST-1 is so much cooler and dimmer than our Sun. Atmospheric models suggest that liquid water could exist on the surface of at least 3 of those worlds. TRAPPIST-1 is a red dwarf. This is critical. Red dwarfs are the most common type of star in the galaxy, accounting for approximately 70% of all stars. There are an estimated 100 billion red dwarfs in the Milky Way alone. If even one planet in the TRAPPIST-1 system harbors life, even microbial life, even a biofilm on a wet rock, then every red dwarf system in the galaxy becomes a candidate. The dominant habitat for life in the Milky Way would not be rare Earth-like planets around sun-like stars. It would be rocky worlds around dim red dwarfs that burn for trillions of years, far longer than the current age of the universe. TRAPPIST-1 has been producing stable energy for its planets for an estimated 8 billion years. That is nearly twice the age of Earth. Whatever is on those worlds has had twice as long as life on Earth had to develop. Number 2. The organic chemistry of the cosmos. Life's ingredients are the universe's default state using the Atacama Large Millimeter Array, ALMA, and a network of radio observatories. Astronomers have spent the last 2 decades cataloging the chemical contents of molecular clouds, the cold, dense regions of gas and dust where new stars and planets are born. They found glycolaldehyde, a simple sugar, and a molecular precursor to RNA, drifting in an interstellar cloud 26,000 light-years from Earth. They found ethanol, acetone, and formamide, molecules that under the right conditions can spontaneously assemble into nucleobases, the structural components of DNA. In 2023, astronomers reported detecting phosphorus-bearing molecules in a star-forming region, phosphorus being the backbone of the phosphate groups that hold DNA and RNA together. The universe's molecular clouds are not empty voids. They are chemistry laboratories operating at interstellar scales, continuously synthesizing complex organic molecules, then seeding newly forming planetary systems with those molecules as the clouds collapse into stars and planets. Every solar system begins preloaded with the ingredients of life. We did not assemble life's building blocks from scratch on Earth. We inherited them from the interstellar medium, from the chemistry of the galaxy itself. The same chemistry that was present when our solar system formed is present in every star-forming region in the Milky Way. It was present 4 billion years before Earth existed. It will be present 4 billion years after the sun burns out. Life's chemistry is not a rare accident. It is a cosmic constant. Number 1. The age of the universe and the silence that should terrify you. The universe is 13.8 billion years old. Earth formed 4.5 billion years ago. Life appeared on Earth approximately 3.8 billion years ago, just 700 million years after the planet formed, during a period called the Late Heavy Bombardment, when our world was still being struck by asteroids at catastrophic frequency. 700 million years. In cosmic terms, this is fast. This is extraordinarily fast. Astrobiologists now argue that life on Earth did not slowly, laboriously bootstrap itself across billions of years. Life appeared at the earliest chemically possible moment. As soon as the conditions allowed it, it was there. This changes everything. It means life does not wait. It does not require long, stable periods of calm. It erupts as soon as chemistry permits. And in a universe that has been forming rocky planets around stable stars for over 10 billion years before Earth was born, this implies something enormous. There are planets in this galaxy that have been habitable for 10 billion years longer than Earth. If life on those worlds followed the same timeline as Earth, erupting at the first chemically available moment, then whatever lives there has had 10 billion additional years to develop. Not a few thousand years ahead of us. Not a few million. Billions. A civilization that emerged on a planet formed shortly after the first heavy elements appeared in the universe could be 2 billion years older than humanity. 2 billion years. We went from stone tools to nuclear reactors in 10,000. We went from the Wright brothers to the moon in 66 years. We cannot meaningfully imagine what 2 billion years of technological development produces. We have no framework for it. It is as far beyond our comprehension as quantum mechanics is beyond the comprehension of a bacterium. And yet, silence. The sky is quiet. SETI has been listening for decades. We have detected one unexplained signal in 47 years. We have found no megastructures, no Dyson spheres, no directed transmissions, no signs of cosmic engineering on the scale a multi-billion-year civilization would produce. The universe should be full of them. By the math, by the chemistry, by the age of the cosmos, they should be everywhere. The silence is not reassuring. The silence is the most disturbing data point in all of science. Something is out there. The math is unambiguous. The chemistry is settled. The scale is overwhelming. Every discovery we make, every extremophile, every amino acid in space, every ocean moon, every organic molecule in an interstellar cloud, moves the probability further from maybe and closer to certainty. The question has shifted. It is no longer are we alone. It is why can't we see them? That question, the silence, is the most terrifying thing science has ever produced. If you want to see more videos like this, click the video on screen now.